Hello, this is my lab report for Lab 1, charged tapes. In this lab, we will analyze the interaction between two charged pieces of tape. Afterwards, we will make a glow script model, assuming we have 2 point charges. And in this experiment, we'll be analyzing the static equilibrium between gravitational and electric forces. A brief preview of the result is that we found that each tape had around a charge of 2.8 times 10 to the negative 9 coulombs. On Earth, we know that the force due to gravity is negative mg in the y direction. With some assumptions that we'll discuss later, we know that the electric force is 1 over 4 pi epsilon 0 times q squared over d squared in the y direction. We're interested in static equilibrium, so that is when F net, which is Fg plus Fe, equals 0. On the right, you can see a free body diagram that represents this. Assumptions and reasonings. We are interested in static equilibrium because we want to do calculations when the momentum of the tape is not changing. Additionally, for simplicity reasons, we will say that the charges of the two tapes are exactly the same and that each tape can be modeled as a point charge. We'll also say that we are only concerned about the electric force between the tapes and gravity from the Earth. System versus surroundings. Our system will be the piece of tape that is placed at the top. Our surroundings will be a piece of tape that is placed below it and the Earth. Initial conditions aren't really applicable for this lab, but technically in the experiment, the initial condition will be when the tapes are held really far away, such that they do not exert a significant force on each other. And the final condition that we are really concerned about and will analyze is when the two pieces of tape are held such that they are in static equilibrium. In our model, the results will be determined by the lengths of our tape and the distance we measure between the tapes. Experiment process. So to get a charged tape, we will put a piece of tape on top of another piece and then rip the top piece off quickly. And then we'll repeat that whole process again so we can have 2 charged tapes. Now we'll place one charged tape so that it's horizontal with a slight sag in the middle. And then we'll take our second piece of charged tape, place it underneath, and wait for the top tape to start floating. Then we'll measure the distance between the two tapes once the top tape has stopped moving. Here's some photos to demonstrate what that looks like. Now for the coding process. We start by setting all of our constants, and then we do our inputted values we got from our experiment. We can calculate some basic values like the mass of the tape, assuming that we have 1 gram per meter. And then we'll calculate our gravitational force. We know that the magnitude of our gravitational and electric force must be equal since we have static equilibrium. So we can do some algebraic rearranging to get the formula for the charge of a single piece of tape. And then down at the very bottom, you can see our visualization steps. Here's the result from our models. At the bottom, you can see some of the numbers from our calculations, and at the top, you can see how the electric and gravitational forces are equal but opposite. Similarities and differences. In both the model and experiment, we found that we had static equilibrium where the forces canceled out. However, in the model, we assumed a very simple point charge interaction instead of the more complex experimental ones, where there's charges dispersed throughout the entire piece of tape. Source of error. So our model had some very large simplifying assumptions that may not give us the most exact results. In our experiment, there may be some error from poor tape handling or imprecise measurements. What if electrons had positive charge and protons had negative charge? Well, in our experiment, we found that our charged piece of tape had a positive charge because it was attracted to a negatively charged pen. Now, if everything was flipped, none of our observed interactions would change because the opposite charges would still be opposite and attract, and the like charges would still be like charges and repel. Why is it important to handle the charged tapes as low as possible? Well, let's say if they were to come into our hands, for example, there would be some charge transfer, and that would lead to inconsistent and imprecise results. In conclusion, we found that each tape had a charge of around 2.5 times 10 to the negative 9 coulombs. There was a deficit of 1.58 times 10 to the 10 electrons on each tape, and that our gravitational and electric forces were able to cancel out and create a net force of 0. Thank you.